gone through how to have students access through number talks, how to build their understanding through the CRA model. Now we're going to look at the why, the what, and the how of learning through internalizing for word problems through supporting students using attack strategies and schemas. So, why are word problems so challenging for students? As you see on this slide, multiple steps are required, with each step offering up an opportunity to go astray and end up achieving an incorrect solution. Reading ability can also interfere with being able to access the mathematics at hand. In addition, the cognitive load of solving application problems is high, and we know that students with mathematical difficulties and disabilities struggle more than their peers when solving word problems. Often, as educators, we try to support struggling learners with tricks to help them through the process with more ease. In this video, Sarah Powell will explain why trying keywords to specific operations is problematic and can often cause confusion when introduced to problem types and tasks that are not as straightforward.
Hi, welcome to this Stair Tailored. I'm Sarah Powell from the University of Texas at Austin, and we're focused on word problem instruction. And right now we're going to talk about not using keywords in word problem instruction. Let me show you a little bit about why this is problematic. So here are some examples of keyword posters that you might see in teacher classrooms. And what students end up doing, especially students that have learning difficulties, is they start to play a matching game between a word and the operation. So for example, over here, I see the word total, and what's really close to the word total? A plus sign. So then students are signaled that every time they see total, they're just gonna add numbers together. And sometimes that works, but sometimes that doesn't work. So here are some examples. In this green example, Casey made $42 and Mandy made $37. How much money did they make in all? So in all is one of our key terms. I see it here on this poster and it's in a plus sign. So I'm gonna add those numbers together. And if you add 42 and 37, you will answer that problem correct. But look at this one. Casey and Mandy made $79 in all. If Casey made $42, how much money did Mandy make? So here's in all, I'm going to add, but when I add 79 and 42, we are not gonna get the correct answer to the problem. So here's an example where the key term in all works. Here's an example where in all doesn't work. And the same thing here. Here's where an example where more works and more doesn't work. We see the same thing with subtraction. Here, more than works as a subtraction term, more than doesn't work. Here, takes away works and takes away doesn't work. Now, you might think, well, that was just for addition and subtraction, but it's also for multiplication and division. Here, twice works as a multiplication term, twice doesn't work. Here, each works, each doesn't work. And the same thing for division. Share and each work for division, share and each don't work, half works for division, half doesn't work for division. And the big problem with keywords is that they never work in multi-step problems. So here I might take this term back and think like, oh, I'm subtracting. That is not going to help us at all with this multi-step problem. And starting in 3rd and 4th grade, students are solving lots of multi-step problems. So why would we teach keywords when they're not going to work in any of those situations? Now, the one thing I do want you to think about is that students do need to understand these key terms. It's important to know what twice means, and it's important to know what each means, and per, and more than, and all of those words. But don't tie a specific term to an operation. So never say something like, well, whenever you see share, that means you divide. That's not helpful for students because share doesn't always mean that you're going to divide. Sometimes you're going to share with subtraction. So it can't be tied to one word. In the same way is that we shouldn't do things like this. We shouldn't present word problems to students and announce at the top of the page, guess what we're doing today? Long division word problems. Here, this doesn't make students read the word problem. This doesn't make students think about the word problem. So this also is an ineffective strategy. So in this Stair Tailored, we talk about not using keywords and not defining word problems by their operation. Instead, I hope you'll tune into the other Stair Tailored, where we talk about effective word problem and strategies, including using attack strategies and focusing on word problem schemas. See you later.
Do your students process for what to do when they see a problem with a mix of words and numbers? Is this common across the school, or do students need to learn a new process every year? Think about these as you hear them from Sarah Powell about having an attack strategy to support your learners.
Hey, welcome to this Stair Tailored. My name is Sarah Powell and I work at the University of Texas at Austin. And in this Stair Tailored video today, we're focused on effective word problem instruction strategies, and we're going to talk about the importance of using an attack strategy. Now, an attack strategy is a way to help students work through a word problem, because what a lot of students struggle with when it comes to problem solving is kind of like knowing how to approach the problem. So let's go ahead and look at a few different attack strategies. And I'm going to scoot over here and do just a little bit of writing, okay? So look at each of these attack strategies. These are common attack strategies that are used in schools. All of these attack strategies on this slide, and this is not always necessarily true, but they're all mnemonics. So they have one word that kind of helps you remember what is the attack strategy. So for this is an attack strategy called ridges, and we see star. I see the attack strategy of rice, and this one is called ride. Now, across attack strategies, there's some commonalities. So I always say that I don't really care which attack strategy you use, I just want your attack strategy to include these things. So the first thing that I notice is that I see in ridges, I have to read the problem. In star, I have to stop and read the problem carefully. In rice, I also have to read the problem. And look, in ride, we have to read the problem. So the first really important thing in a good attack strategy is that we read the problem. And what's the first thing that a lot of students don't do when they see a word problem? Guess what? It's to read the problem. So we need to remind students to do that. Then I see in all of these, so here students kind of talking through and drawing a picture. Here we're making a plan. Here they're also drawing a picture. Here they're identifying the relevant information and determining the operation. So the next thing that's really important in any attack strategy is that we make some type of plan. So it might be drawing a picture, it might be using manipulatives, it might be using a graphic organizer, it might be talking through your thinking, but you're making a plan in some way. Now, the next thing that I see with all of these is that I'm going to solve the equation. Here I'm going to solve the equation. Here I'm going to compute. That would be solving an equation. And here I'm going to calculate, all right? So these all involve some type of solving. So I'll go ahead and write that right there. Then the final thing, and not all of these have it, but I think it's really important. So I don't see it in ridges, but I do see it in star. I see we review our answer, here we explain our thinking, and here I'm going to check my work. So I always think like a check or a review, I'll actually just write check, okay? So any good attack strategy includes these components, and it might include a few more components, and that's okay, but you really want it to help students set up and solve the problem correctly by reading, making a plan, solving, and checking their work. So let's look at a few other attack strategies and see if they include these components. So here are two attack strategies. These are some of the ones that you can buy at your local parent-teacher store or online. And here we have pause. I see read the problem, analyze, work it out, and solve. That's doing pretty, it's aligning to our components right there. And here we have super. I read the problem twice, I underline the information, so I'm making my plan, I solve the problem, and then here I could actually rewrite my answer in a sentence if we wanted to. So that could be part of checking our work. Here are some other attack strategies. Here we have shines and solve and signs. Each of these, students are reading the problem, they're finding the important information, so they're making a plan. Here they're solving, and then they're going back and checking their work. So each of these attack strategies, that's kind of hard to say, include our important components of an attack strategy. Here are two other attack strategies. Let's see. Now with these two here, we've got sweep and we have bugs. Let's go ahead and look at sweep a little bit. Here with sweep, I see that the first thing is to do something with symbols. The first thing is not to read the problem. So I don't think this is like a very good attack strategy. So you could do two things. One, you could not use it, so we could cross that one out and not use it. The other thing is that you could add read to the list of the first thing that you do with the attack strategy of sweep. The same thing here with bugs. Notice the first thing in bugs is to bracket or put some brackets around the question. It really isn't emphasizing the reading of the problem. So again, we might choose to not use the attack strategy of bugs. The other thing we could also do is just add read to the bug strategy. So instead of bugs, maybe it's our bugs. Instead of sweep, maybe we call it our sweep. And it's not as cute and easy to remember, but it does emphasize that we have to read these problems to help us work through the word problems. And then guess what? My marker just falls all over the place. I'm going to go ahead and erase these right here because I don't want that read to be on the next slide. So let's look at a few other attack strategies. This is one of the most popular attack strategies that we see used in schools, and this one is called cubes. But notice these two versions of cubes or cube don't include that reading component. Remember, that reading is absolutely essential. So I like to turn cubes, if you're going to use it, you got to turn cubes into R cubes. And there is one thing down here. Notice that it says circle the key numbers and box the action words. Do make sure that if you do box action words, that's a totally fine thing to do, but don't tie words, a keyword to an operation. And there's another stair-tailored video that I hope you'll watch where it talks about how keywords tied to operations is an ineffective word problem strategy. Now, the other attack strategy that you'll see me use a lot is this one here. This one's UPS check. And here are some different variations of UPS check. But here the students understand the problem by reading it, then they make a plan, they solve it, and then they check their work. And look, those are the really important components of our attack strategy. So I'm glad we have those in our UPS strategy. And that's the one that I'll use the most today, but you're welcome to use any of these. Remember, the important thing is that you have an attack strategy and you use it regularly. So thank you so much for tuning into this stair-tailored video. I hope you'll watch some of our other videos that get into the ins and outs of word problem instruction.
For some of our students, they may be able to move straight into word problems, and we should give them the opportunity to do so. Other students may need more support through schema-based instruction. A schema is a way to organize or pattern information within a structured framework of known and unknown information. Rather than just focusing on keywords or a general solution method such as identify, plan, solve, schema-based instruction looks at problem families and provides an organizational plan that is common to the family. This method has been found to be highly effective, particularly for struggling learners, because it gives students specific strategies for solving the problems. Problem schemas are determined to be either additive or multiplicative, with multiple strategies available for setting up problems within these categories. Older students may combine both additive and multiplicative schemas to solve multi-step problems, such as those involving percent change or calculating a total price with tax and or discount. Just because students approach a problem using the same schema doesn't mean they will solve the problem the same way. For example, two students use a change schema to set up the problem. Emma had $9. Then she earned some more money doing her chores. Now Emma has $12. How much money did she earn? To solve the problem, one student adds on to 9 to get 12, and the other student decides to subtract 9 from 12. Even though they use different operations, they both arrive at a correct answer of 3. For more specific information regarding each of the schemas, follow the link on this slide to Teach Word Problem Schemas to the Stair-Tailored playlist by Sarah Powell on word problem instruction. If the link does not work, there is also a link in our implementation resources for you. Think about your classroom. Does the entire class struggle to identify a problem type? Are there a group of students that pull numbers from the page and just add them together? Or is there an individual that gives up when they see a mixture of words and numbers on a page? Schemas can be done during whole group, small group, or even individual, depending on where your students' gaps are and the number of students struggling with word problems. Look at your data, both summative and formative, to make the decision about where you're going to bring schema-based instruction. Here is a video of schema-based instruction happening in an individual tutoring session. For more information, we have the one-pagers and we have an entire module with more information on schema-based instruction.
Good job. And what does the R stand for?
Read the problem.
All right, let's read it together. Ready? Malik had 2 peppers. Then he bought 3 peppers at the store, and his friend gave him 4 peppers from his garden. How many peppers does Malik have now? All right, so we read the problem. What do we do next?
Underline the label and crash out irrelevant information.
Perfect. All right, let's look at our question sentence to see what our best label is. It says, how many peppers does Malik have now? What are we talking about?
Peppers.
Good job. So what are we going to underline?
Peppers.
Good job. Let's go ahead and look back at our story. We know our label is,
Peppers.
is everything in the story talking about peppers?
Yeah.
Yes, do we have any irrelevant information we need to cross out?
No.
No, we're done. So what's step number 3?
Name the problem type.
All right, let's name the problem type. Let's use our handy dandy questions poster to help us out with that. All right, if it's a total problem, what do we ask ourselves?
Are there parts put together to total?
Good job. If it's a difference problem, what do we ask ourselves?
Is there 2 amounts compared for a difference?
Good job. Remember, in difference problems, we have a what?
Compare word and compare sentence.
Killer. All right, and if it's a change problem, what do we ask ourselves?
Is there a start amount that increases or decreases to an amount?
Perfect. What type of problem is this? What is this problem doing? So,
Increasing.
Malik, good job. Malik had 2 peppers. Okay, we know he has 2 peppers. Then what happened?
Then he bought 3 more.
He bought 3 peppers. Good job. So this is, what type of problem is this?
Is it increase?
So, but what type of problem is it? A total, difference, or change?
Change.
All right, so first let's put our C. Good job. And now let's see what's going. So you said Malik had 2 peppers, then he bought 3 peppers. You said it was what?
Increase.
Increasing. So what sign are we going to put?
Plus.
Are we done there?
No.
No. And then his friend what?
Gave him 4 more peppers.
So what's happening there again?
It's increasing
It's
again.
increasing. Good job. So in this change problem, how many changes do we have?
2.
Good. And both of them are increasing. Excellent job. All right, so we used our run poster to help organize our story. Let's go ahead and use the change poster to solve it. All right, what's step 1?
S, T,
Remember, we have 2 changes here, so I want to see.
plus C.
Perfect. Excellent job. You just earned yourself a treasure coin because you remembered how to write your change equation when we have 2 changes. Oh, reach. Good. All right, so you rolled your equation. Next, we gotta what? Do what?
Find our start amount.
Let's find our start amount. How many peppers did Malik start with?
2.
Good job. So it's good job. What do we do to the 2 in our story?
We did 4.
Not circle it. What do? If we already used it, remember we always put a check mark.
Oh yeah.
Good job. So the reason why I put a check mark is, hey, we already used this number. We don't look at it anymore. All right. So let's go ahead and find our C. What's our first change? So you had 2 peppers. Good job. You got 3 peppers. Excellent job on remembering to check mark the number. All right. We have another change. What was our second change?
4.
Good job. All right. What's step 4?
Find E.
Oh, good job. Find E. What's your end amount? Do we know how many peppers Malik has now?
No.
Isn't that what we're trying to find? Good. So what are we going to mark
It
under?
is.
Good job. All right. Now we need to write our missing signs. What signs are missing?
The plus, and the zero sign.
Good job. All right. Now all we got to do is we got to find X. Remember when we solve for X, we need to isolate the X. What does isolate the X mean?
Isolate the X means when we want a number by itself.
Good job. We want X by itself. Let's look at X. Do we need to isolate X here?
No,
No, why not?
it's already isolated.
It's already isolated, so all we got to do is solve. Are we going to add or subtract?
Add.
Good job. So we let's break this down into steps if we need help. So first we can add 2 plus 3. What's 2 plus 3?
2 plus 3 is 5.
All right. Plus.
4 is 9.
Good job. So what's our answer?
9
What do we remember? Our answer should always have a
number and a label.
good job. So X
X is the same as 9
9 what?
peppers. peppers.
Good job. Excellent job. I see a number and a label. Good job. All right, all we got to do is check our answer. Does our answer make sense? Yeah. So we have a starting amount that keeps increasing. Is our end amount going to be bigger or smaller?
Bigger.
Good
Because
job.
if we have a smaller start amount, then our end amount has to be bigger.
Good job. He keeps getting more and more peppers, so it makes sense that our end amount, 9, should be bigger than our start amount too, right? Good job, Esther. You're going to earn a treasure coin because you did awesome at solving problem A. All right, let's look at problem B. All right, what's